And remember, we configured a scenario and then we executed these commands to configure uh, OSPF, right? Router OSPF, uh, followed by the daemon process or the process ID, because we said this, if you remember, that OSPF, though it's a network layer protocol, but it is run as an application process, and we need to provide the process ID, and it's also known as a daemon process, okay, background process, I mean to say. And then we said, okay, fine. After that, we need to provide the network. For example, 192.168 dot 1.0 followed by the wildcard mask. Okay, और हमने कहा था कि wildcard mask is exactly opposite to uh, subnet mask followed by the area, say 0. So this is wildcard mask, and a wildcard mask can be calculated. How is widely used in, by the way, access control lists by subtracting it, the subnet mask from 255.255 dot 255 dot 255 minus the subnet mask. Okay.
Mask.
Okay. We can get the, and it has a lot of, its use is immense when we talk about the access control list. Okay. So wildcard mask indicates that which bits of IP address should be ignored, that we talked about last class. For example, zeros should be matched, right? All these zeros must be matched. Okay. And all the ones, I mean, 255 means all ones in this octet, right? It can be ignored. So it's important from where the packet, the data is coming in, the network, and from that network, any machine's data can be passed on. Okay. And then we said that, okay, this is followed by the area, and area have a number. So what we do in OSPF is that we divide a larger network into different areas to reduce our complexity. So I would like to continue our discussion from here so that we can dive deep into this notion of area, or the need of dividing network into different areas. So we divide OSPF uh, based network into different areas, right? And why do we do this? We do this to reduce complexity of network, complexity of network. Because if the network size is more, the larger will be link state database. So we can have different types of areas. For example, we can have backbone area. Backbone area is always area 0. Okay. So then we have stub area, and then we have totally stubby area. Then we have not so stubby area, also known as NSSA. And then we have totally not so stubby area. And then we have a standard area. And these areas can be understood, right? Only if we have knowledge of different types of uh, link state advertisement. So these areas or these types depend on these types depend on link state advertisements, also known as LSAs. Okay, right? So there are different link state advertisement updates in OSPF. So different types of LSAs, uh, understanding of different types of LSAs will help us to understand different these different areas. So these are the different types of LSAs. So first of all, let me list different types of link state advertisements, and then we'll try to link the both to understand what we mean by different link states and different areas. Okay. So, link state advertisements, um, LSA types. These are the different types of LSAs. Number one, we have LSA 1, link state advertisement 1. And this is the advertisement update message from a router to its neighbor, right? So, this is from router to neighbor in an area. Okay, router to neighbor in an area, and we can categorize this as intra area, that within an area, right, a router is sending update to its neighbors. Okay, this is one. This is first type of LSA. Am I clear? The second type of LSA is LSA 2, link state advertisement 2, and uh, and this is known as network, right? So this is router to neighbor. This is about the network information. I mean, of an area. Okay, this is again can be categorized as inter area. This is again intra area. But this is by a designated router, right? This is intra area done by. So this is intra area done by a designated router. So um, we designate a router to send the area level information to all the routers, right? By the designated router. This designated router is also known as DR. Okay. Then the third type is, we call it LSA 3. This is known as network summary. Um, this network summary, this is inter area, right? I mean, we are sending update in between different areas, inter area, and is done by area border router, ABR. Okay, so this means what? This means it summarizes network uh, from one area and advertises to the another area. इसका मतलब क्या है LSA 3 का? इंटर एरिया है. This means it summarizes network from one area and advertises um, to another area. Okay, so we take a summary of one area and then we pass it to the advertise it to the another area. Okay, so this is LSA 4. Then we have link state advertisement 3. Sorry, link state advertisement 4, and this is known as ASBR summary. This ASBR is autonomous bound system boundary router. Autonomous uh, autonomous systems are rather any network, right? So for example, CUI's network is an autonomous network, right? So there would be a router through which we are connected with the internet, and that router is known as ASBR, right? Autonomous system uh, boundary router. Okay, so what does this mean? And this means that area border router, this is important for us to understand. This means what? This means what does this ASBR summary means? This means area border router, ABR, right? Tells the info of path to ASBR, right? Autonomous system boundary router to all other routers. Okay, in other areas. Okay, so दोबारा से देख लिए LSA 1 is a simple routing update that a router sends to its neighbors. Okay, simple. And LSA 2 is a network wide update. I mean, it's again intra area where a designated router sends the information of all the routers uh, uh, to the routers in the network, right? So for example, in LSA 1, I only know about my neighbors, but in LSA 2 update, I know about all the routers in the area. Clear? LSA 3 is network summary, where I summarizes an area information and I send it to the other area, advertises it to the other area. And an LSA 4 is that area border router tells all the routers the path to the autonomous system boundary router. Okay, and then we have LSA 5. LSA 5 is known as this LSA 5 is known as external summary, right? Excuse me. LSA 5 is known as external external summary. External summary means it advertises uh, routes from outside the OSPF autonomous systems. For example, there's a path that we have learned from any other network inside our network, right? So may I like that one. So this means it advertises routes from outside OSPF, um, autonomous system. For example, routes learned learned from BGP border gateway protocol or any other static routes or static. routes. Okay. So LSA 5 means that this is a summary that we are getting outside the network. So what we have done is in ComSets, for example, we have divided the network into areas, right? Different areas. And if we get, an update outside from the outside the ComSets network, this is considered as LSA 5, right? So the ComSets network is based on, say, OSPF, but maybe the routes that we get out of the network are based on it's a static routes, or maybe based on border gateway protocol. Okay, or maybe based on RIP for that matter. Okay, so then we have LSA 7. Okay, so LSA 7, uh, LSA 7 is used to advertise the external routes. In This is for, by the way, uh, this is for this is also known as NSSA external, NSSA external. Okay, so NSSA हमें पता है, not so stubby area, right? Remember, हमें नहीं पता ये क्या, with a question mark, right? We need to connect all this together. I'm just listing these, right? I have listed different types of areas. I'm listing different types of LSAs. Then we'll try to connect them together to you know, uh, make it understandable. Okay. So LSA7 is known as not so stubby area NSSA external, right? Here, the external summary uh, means it uh, advertises the external routes in NSA, right? And NSSA, right? Okay, right. So obviously we need to connect. We have just listed. देखा हमने क्या किया? We have listed different areas. हमें नहीं पता ये areas क्या है, right? We have listed different LSAs. हमें scope पता है LSA का क्या है. For example, LSA is from one router to the neighbor, intra area, right? Just please ask question. No, there's no, yeah. यहाँ पे इसमें NSA 6 नहीं है. वैसे NSA 6 है. NSA 6 is for multicast OSPFs. Okay, so we are not talking about the multicasting at the government. We are talking about the unicasting, right? There is LSA 6 as well, but at the moment our discussion is related with the uh, unicast routing. And there is LSA 6, and LSA 6 is for multicast OSPF. Similarly, we have LSA 8 as well. This is for the external attributes. I mean, for the BGP, entry router in OSPF. Then we have LSA 9 as well, which is for the opaque link routes. Means वो हम traffic engineering के लिए use करते हैं MPLS. Okay, we have type 10 as well, right? LSA 10, which is again uh, opaque areas. Okay. Then we have different LSAs as well. 11B, which is for opaque autonomous system scope. उसका scope autonomous systems के दरमियान है, right? So there are other as well. I want to say, what are at the moment our a concern is with these LSAs only. So we do have LSA 6, we do have LSA 8, we do have LSA 9, 10, 11 as well. Okay, should we move on? No worries. So now this with the help of a scenario. Let me draw a scenario here. Different areas here. Okay, and for example, this is my in this area. This area I have different routers. I have a router here. There is a router here, right? So this is an area where we have these routers, and this is the interconnection of these routers. Okay, and I call it area 0. Area 0 is what? Remember, area 0 का तो मैंने आपको बताया is what?
Backbone area.
जी आप सही कह
Backbone
रहे
area.
हैं. Yes, thank you. Area 0 is backbone area. Okay, and what do you mean by backbone area? First of all, every OSPF network must have a backbone area, and all other areas must be connected with this, with each other with through this backbone area, which is the case in this representation, right? These are other areas which I will name shortly, right? And all the other areas are connected with each other through this backbone area. Number one. Number two, backbone area can be categorized as based on the LSAs that are allowed in this backbone. So all these LSAs are allowed. Okay. So LSA 1, 2, 3, 4, 5 allowed. So what's the significance of backbone area? Every OSPF network must have a backbone area, number one. Number two, all LSAs from type 1 to 5 are allowed. ओके एंड अब आप मुझसे पूछ सकते हैं 7 हम इसलिए यूज़ करते हैं, यू विल सी इन अ मिनट वेयर द 5 इज़ नॉट अलाउड. ओके, so since the 5 is allowed, so we don't need 7 here. ये आपको समझ आ गया कि what do you mean by a backbone area? Yes, no?
Yes.
Yeah. Okay. So then we have this, stub area. So this is my stub area. It has a router here, and now it is connected with the backbone area. So this is my area, say one. I name it one, area one, and I call it what? Stub area. Remember? हमने यहाँ पे जब लिस्ट किया, अगर आप जाएं दोबारा से, तो हमारे पास बैकबोन एरिया था. बैकबोन एरिया के बाद क्या है हमारे पास? We have this stub area. Okay. So area one is stub. But what do we mean by stub area? So stub area is the area that does not receive external type 5 LSAs, right? For example, there is another network. This is outside this network, and the this area is connected with this network, right? So no external network updates are allowed. Okay. So then, what is allowed as per LSA rule? One is allowed. LSA one is allowed. LSA two is allowed. LSA three is allowed. What is LSA 1? A router can send update messages to its neighbor and can receive update from its neighbors. What is LSA 2? Is a network summary, I mean network wide information that this router, maybe this router is, for example, uh, this router is DR, designated router here, and the designated router will send the information about all the other routers in the area. What is LSA 3, right? From one
Network
area to
summary.
one area to another. So this means here the network summary is allowed. I mean, I can have a summary of this backbone area about all the routers is allowed to be propagated in this area one, which is stub area. Okay, right? No type 5 is allowed. No type 5 allowed. Type 5 allowed. Type 5 is not allowed. 4 is also not allowed. Okay. No type 4 and 5 is allowed. No type 4. So, what can be the use case which defines this, you know, this stub area? So, a network with limited, note कर लीजिए, a network with limited resource or resources where full external routes is unnecessary is will be treated as stub area, right? So, मैं चलिए लिख देता हूँ. So, the use case which can represent a stub area is, so a network with limited resource where external full external routing is unnecessary. External routing is unnecessary. Okay, right? So then we have this question that how you know the external routes will be injected inside this area. For that, we can use default route. Okay, so stub an area where we have this limited resources, right? And the full external routing is unnecessary. So we can use a route to go to this route of instance. Okay, and only type 1, 2, and 3 is allowed. Type 4, 5 is not are not allowed. This area, जब आप समझ रहे हैं मुझे बताइएगा आप. Then we have this area again. It has a router, okay, and I call it say area 2, and say this is my totally stubby area. Okay, so the next area is say G question. What do you? Anyway, this is just for the sake of example. When we write a command, then there we write stubby or totally stubby and all that, right? So this I'm just writing area 1, 2 for our understanding. When I have to declare an area, stubby area, I need to write a command. For example, I would write a command to declare it stubby. Okay. For example, I will write area 1 stub no summary. Okay. This is the command that I will write. मैं लिख भी देता हूँ in a minute. Let me explain it first. So this is yet again another area, right? And now let's say this area is NSSA. I call it area 3, and this area is NSSA. And remember NSSA क्या था भला? Not so stubby area, right? It is like a stubby area, but ये है stubby area ही. मगर इसका नाम देखिए क्या है. बोलिए ज़रा क्या नाम है? Not so stubby area. So this means it's a stubby area, but it is allowing something which was not allowed in the stubby area. Okay, but how we can categorize it uh, in terms of LSAs? One is allowed, two is allowed, three is allowed. All the LSAs are allowed, which was allowed by the stub area. One is allowed, two is allowed, three is allowed, right? And because it is not so stubby area, this means something else is also allowed. So seven is allowed, right? So one, two, three, seven allowed. Okay. No type five. No type five allowed, right? Type seven is used for external routes inside NSSA, right? Using seven, what we can do is uh, we can type 7 can be used for external routes originating inside NSA, right? Okay, so this means type 7 for external routes inside NSSA. Okay, and then the later 7 is converted into 5. So what can आपको not so stubby area समझ में आ गया? 1 2 3 is allowed, 5 is not allowed in stub area, but in not so stubby area 5 is allowed in terms of 7. I mean, external routes are uh, propagated inside NSA using type 7, and then type 7 is converted into type 5. Okay, what can be the use case in which we can use an area or represent an area as uh, not so stubby area, NSSA? Okay, so so you can think of it as a stub area needing some local connection to external network, right? So you can think of it as a stub area needing local connection to external network. Example: example is a branch with uh, border gateway protocol or static external route. So if there is a branch with, or there's a stub area with access to the external route, so for that we need to allow the external summary, right? In stub it is not allowed, but in not so stubby area this is allowed in terms of type 7. Then we have area 4 here. There is another router. This is area 4, and area 4 is what? Totally not so stubby area, NSSA. And what does this mean? This means 1 is allowed, 2 is allowed, 7 is allowed, and others are not. Okay, so you can think of, totally not so stubby area as a combination of totally stub area and NSSA, right? So what is allowed in a totally stubby area? देख के बताइए जरा. In totally stubby area is allowed 1 and 2. Okay, but 3 is not allowed. So 1 and 2 is allowed here, and then 7 is allowed here. So uh, here we have 1 2 and 7 is allowed. No type 4 and 5. 7 is allowed. Okay, no type 4 5 3 is allowed. Okay, um, so this means uh, what can be the use case where we can have this totally NSSA, not so stubby area. For example, in extreme optimization for a remote NSS area, right? For extreme optimization for a remote NSS area. Okay, followed by the IP address and subnet mask, we need to give the area. And for in order to understand the area, we need to know that this link state database, right, that we maintain on a router, in the case of uh, OSPF network, we need to break it down, right? So that we need to send less number of link state advertisements. For that, we need to divide our area into different types of network into different types of areas, so that we can limit the link state advertisements. Okay, so we have different types of areas in which we have standard area, backbone area, then we have stub area, then we have totally stubby area, not so stubby area, totally not so stubby area, and these areas can be classified based on the types of LSAs allowed. I mean the uh, rules, LSA rules, what LSAs are allowed and what are not allowed inside the network.